First 5 problems ask us to find the mean and standard deviation of the given binomial variables. In general, this is easier than the formula we had to deal with before, so we should be happy to see finding the mean and standard deviation. The formulas are pretty straightforward. The mean is just n times p. How many times am I going to run the experiment times the probability of success on the experiment should tell me how many times I expect to be successful. Standard deviation is a little trickier. Basically, sigma just equals the root of n times p times 1 minus p. Still, a lot better than the formula we've had to use thus far on this page. So when I go to do number 7, and I'm calculating the mean, I should just be doing 3 times 0.7, which gives me 2.1. When I go to calculate sigma, I should be doing the root of 3 times 0.7 times 1 minus 0.7. Make sure that everything is happening under the root, so you might need some extra parentheses to keep it that way. But as long as you do 3 times 0.7 times 1 minus 0.7, all happening under the root, you should get an answer of 0.7937, which I'm going to call 0.794. Again, as I've warned before when I'm doing this rounding, always make sure you're checking in the cent-gauge question if it asks for a specific rounding. Otherwise, I tend to go to 2 decimals. Here I went to 3, but really if you went to 2, that'd be fine, and call it 0.79. For number 8, when I go to find the mean, that's going to equal 10 times 0.6, or 6. In other words, if I'm a 60% free throw shooter, and I'm going to take 10 free throws, you expect me to make 6 of them. Standard deviation equals the square root of 10 times 0.6 times 1 minus 0.6. When I put that in my calculator, the root of 10 times 0.6 times 1 minus 0.6, I get that to be 1.549. For number 9, the mean is going to be 5 times 0.9, which gives me 4.5. The standard deviation is the root of 5 times 0.9 times 1 minus 0.9. When I put that in my calculator, the root of 5 times 0.9 times 1 minus 0.9, I get that to be 0.671. For number 10, the mean is 14 times 0.92. I get that to be 12.88. The standard deviation is the square root of 14 times 0.92 times 1 minus 0.92. Square root of 14 times 0.92 times 1 minus 0.92 gives me 1.015. Finally, the mean for number 11 is n50 times p.15. When I do that, 50 times 0.15 should give me 7.5. The standard deviation is then found as the root of 50 times 0.15 times 1 minus 0.15. When I put that in my calculator, 50 times 0.15 times 1 minus 0.15, I get that to be 2.525. 2.525. So again, this is really just applying these 2 new formulas that we have. The mean, just take the number of trials times the probability of success. The standard deviation under the root, take number of trials times probability of success times probability of failure. Number 12 is a word problem. Really, I just need to try and convert these words into symbols that we've been using on the front side here. So, suppose the probability of a swimmer beating his personal best time at a meet is 0.25. The fact that it's a decimal should clue me in that it's the probability I'm going to be using. It says the probability of something happening. Really, I need to pull out that this is my p, 0.25. Assuming this follows a binomial distribution, And there are 8 meets this year, so this is going to be my n. N equals 8. He has a probability of 0.25 of beating his personal best at n equals 8 meets. Find the probability he beats his personal best time in 1 meet. Well, what that's really asking is what's the probability he has exactly 1 success. We know to find the probability for 1 success, we take n, which we identified as 8, NCR1, times the probability of success, which we identified as 0.25, to the power of successes, times 1 minus the probability of success, to the power of n minus successes. So when we do this for 1 success, we can just put it in as 1 time through the formula, 8 NCR 1, 0.25 to the power of 1, and parentheses, 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 1 minus 0.25 to the power of 8 minus 1. And parentheses, I get this to be 0.2669, which I'm going to call 0.267. So the probability of exactly 1 success is 0.267. Find the probability he beats his personal best time in at most 1 meet. At most 1 means 1 or less. If I ate at most 1 hamburger, I couldn't have eaten 2 hamburgers because I had at most 1. So this is really asking me to find the probability that x is less than or equal to 1, which really is the probability that x equals 0 plus the probability that x equals 1. We already found the probability that x equals 1 above. So the only new time I'm going to need to run the formula is for the probability of x equals 0. That's going to be 8 NCR 0, 0.25 to the power of 0, 1 minus 0.25 to the power of 8 minus 0. If I put that all into my calculator, my calculator tells me that as probability 0.100. Now that we have 0, above we had 1, we can find the overall probability of at most 1 as 0.100 plus 0.267, which gives me an overall probability of 0.367. For part C, it says find the probability that he beats his personal best time in more than 1 meet. To understand that from a sample space perspective, here's all the possible meets that he could beat his personal best time. Everything from 0 meets beating it up to 8 meets beating it. If it's going to be more than 1 meet, these would be the answers that we're looking for. More than 1 includes 2, 3, 4, 5, 6, 7, and 8. But it's easier if I see the problem as this whole sample space counts as 1 or 100% of the things that can happen, what's not included. So I could get the right answer by running the formula 1, 2, 3, 4, 5, 6, 7 times. Or I can say to myself, well, instead of running it this 7, I just want to figure out which the things that don't count and subtract that from 1 or 100% of the probabilities. The things that aren't going to count are this 0 and 1, and good news, they're the exact things we found above. So since we already know the probability of 0 and 1 is 0.367, if we take 1 or 100% of the things that can happen, subtract out this 0 and 1, which has probability 0.367, we'll be left with all these probabilities added together without having to run the formula 7 times. If I do 1 minus 0.367, I should get 0.633, which is the correct probability for the probability he beats his personal best time at more than 1 meet. Final thing it asks me to do with this word problem is use the information I have to find the mean and standard deviation. Really, these are the only 2 things that I need, the same things that I had above. So if n is 8 and p equals 0.25, the mean mu equals 8 times 0.25, which gives me 2. On average, if he goes to 8 meets, he should have 2 times where he meets his personal best. If I go to calculate sigma, I'm going to put it under the root, do 8 times 0.25 times 1 minus 0.25. When I put that into my calculator, the root of 8 times 0.25 times 1 minus 0.25 gives me 1.225.